Rocking and rolling. We're up to this subject. It's more of a physics. Well, not more of a physics concept, but it is a physics concept. So, 621, Intro to Vectors. It's a symbol, there it is, symbol of force and direction. So if you hang a sign, you know, it's got the chains. Those are vectors. They're holding weight. So an airplane, that's a vector. Somebody using a two-armed shiver, that's a vector. So all these things, very applicable to life, but we're just going into the very basics today. So here we go. Back in the days of geometry, you were taught about a ray. A ray, like a sun ray, has a definite beginning, like the sun, and it's shooting off light, but these go on forever. It doesn't matter how long you make it, these rays have a beginning, but they have no ending. The difference is, in the world of vectors, you have a definite beginning, and the end of it is the end. That's where it stops. So this vector, maybe it's 10 pounds. This is about half, so that'd be about half the force. So it's also direction. So this is heading literally a little north and a little west. Is that right? A little east, sorry. So anyways, force and direction. Okay. I was literally looking out the window and that's west. But on a map, you'd be saying, hey, it's east. So anyways, forgive me. So let's just dig up the basics right now. It says let P be 4, 2. So 1, 2, 3, 4, 1, 2. There it is. Now notice P comes first. That is very significant. That is the beginning. And then we've got Q, which is 7, negative 2. So 4, 5, 6, 7, negative 2. Right here. That's where it stops. So I'm going to label this. And P is 4, 2, and that Q right here is 7, negative 2. Now I'm going to open up your eyes for something. We've been dealing a lot with the idea of you spin your spinner like 150 degrees, stops here, that's 30, you make a triangle, that's 1, that's 2, that's the square root of 3 negative. You can find all these trig functions, and when you find trig functions, there's a whole bunch of things that can apply to that. So with that being said, there's a formula called component form formula, and here it is, x2 minus x1, comma y2 minus y1. What in the world am I talking about right now? Why did I just talk about a spinner? Well, right now, this vector is not a spinner. So if I say this is x1, y1, which it is, because that's the starting point, this must be x2, y2. And you have to label it correctly for this formula to work. So what's x2? 7. What's x1? 4. Let's see what this does. y2 is negative 2. y1 is 2. So if I clean that up, that'd be 3, comma, negative 4. Now, what is this? That is the end point of a vector, of this vector, if this beginning point is translated to that. So that's what this formula does. It takes the origin, it makes the origin the beginning. Now, why is that significant? We'll talk about it in a minute. Let's just find out where that endpoint is. 3, negative 4. 1, 2, 3. 4 is right here. Now, my drawing's not perfect, but does this look like the same thing as this? Yeah. I mean, again, my drawing's not perfect. But this formula translates this vector out in no man's land so that now it's stuck right there. So now it has become a spinner, which now we can apply triangle logic, we can apply trigonometry to it. So this is a very, very, very valuable formula, so get used to using it, okay? Let's stop right there for a second. Moving on in the world of vectors. So, remember what I said, a vector is a symbol of force and direction. So now we're going to talk about both. Magnitude is the word that gets connected to the world of vectors, which represents the power of the vector. So if you have a big old oak tree fall, that has tremendous power. down and out. So that's all the world of physics. But so if you have a vector, now notice these little pointy things on the end, that means a component form vector, which means the origin is where the vector begins. This symbol right here is the symbol this book uses for magnitude. Now in a previous book, it was just this. So it looks like the absolute value. So I think they try to get away from the absolute value looking thing in this book, so they add more lines. So if you see me not writing all of those things, you can just forgive me for that. But here's the formula. Now you might say, well, that's a fancy formula. Well, not really. If you take a look at this, now let me get rid of that, and you actually make a triangle, this would be 3. Technically, this is -4 because it's 3, -4. And I went, hey, a squared plus b squared equals c squared. You know, you would go a squared plus b squared equals c squared. Some of you are like, get on with it. It's already 5. You know, if you remember your geometry, 3, 4, 5. But I just want to show you the Pythagorean Theorem is hidden in there, so you don't really have to memorize another formula. So this is just 9 plus 16 equals c squared. You can see this is 25. And so you take the square root and you get 5. That is the magnitude, okay? So the length of the spinner, the hypotenuse of your right triangle, however you want to think of it, the length of the vector is the magnitude, okay? So now what is this? What is find the direction angle of 3, -4. Now there's a lot to this. This goes back to a previous lesson. Where's the reference angle? The reference angle is right here. So we'll talk about, well, is that going to be my answer or not? But we've got enough tools in our toolbox to figure this out right now. So if I looked at this, and then this, and this jumped down in my head, I'd go sine of theta equals -4 fifths. Now, another student might have this and this jump out at them, so they would go tangent of theta equals -4 over 3. And then one more color. Another student would look at this reference angle, would look at this and this. And so they'd say cosine of theta equals 3 over 5. Each one of these approaches has its own little twist, so let's talk about it. If I looked at this and I wanted to figure out what theta is, I would have to do the inverse sine. So I'm going to go second sine -0.8. By the way, don't use your subtraction sign for your negative. You got to use the negative sign there on the key. And so enter, and I get -53.1. Let's do this one. Second cosine 0.6. Enter. This one, I get 53.1. It's like, wait a minute, how come they're not the same? And then let's go to this one. Second tangent, -4 thirds. And this one gives me -53.1. So you can see there's a consistency, but how do we interpret this information? Well, just so you know, does -53.1 look right? For example, if this spinner was right here, so 1, 2, 3, 4, 5, there it is when it starts in initial position. If I flip it down 53.1, it's like, yeah, that looks right. So I get that answer twice. Why did the calculator give me 53.1 for this one? Because your calculator has no idea that you are in the 4th quadrant. So the calculator says, where is cosine positive? The first thing they're thinking is up here, because yeah, this is 3, this is 5, that's 4, so your calculator took you up here. You need to look at the picture and go, aha, it can't be positive 53.1 because I'm in the 4th quadrant, so it has to be negative. Now sometimes books will force you to get there only in a positive direction. So the direction angle would be 360 minus 53.1, which is 306.9. So be aware of that. They might have some restrictions on it, and you have to pay attention to it. So they may say something like this, and if you ignore it and you put negative 53.1 down, that doesn't fit in between 0 and 360. Pay attention to these clues in the math problem. So there you go, not quite done. All right, so we're moving ahead. So vector B has a direction 210, magnitude of 8. So we're going to make this 8. We're going to flip it 210. That means positive. There's 90, there's 180, another 30. Be accurate with your drawings, you guys. And there it is. Okay, it says sketch it in component form. Well, there it is. But if they say find it in component form, they're actually saying build your triangle, find your x, find your y. Well, that would make this 30, 90, 60. Well, my 30, 60, 90 rules say that y has to be 4, but that would be down to get to the end of the spinner there. And then this would be 4 square root of 3, but that would be negative because that's left. So component form would be negative 4 square root of 3, comma, negative 4. We did it. But in vector world, unit vector means the magnitude equals 1, and it's very useful. So we have a magnitude of 8. We want to convert it to something that has magnitude of 1. Here's a formula. So this just says take the original, negative 4 square root of 3, negative 4, and you're going to put A, which is that unit, negative 4 square root of 3, over its magnitude, which is 8. Then you're going to take B, which is negative 4, put it over the magnitude, which is 8. This reduces to negative square root of 3 over 2. This reduces to negative 1/2. So what it did was, it literally chopped off 7 of the units. And if we plotted that point and that point, this distance would be 1. You could use Pythagorean Theorem, a squared plus b squared equals c squared, and you would find out that, yeah, the hypotenuse would be 1. But I'm not going to take up video time to show you that. All right, so this one math problem pulls it all together. So it says h is a vector from 6, negative 1, so that's x1, y1, to negative 3, 6, that's x2, y2. So there it is. First question, component form. So that is x2 minus x1, and then y2 minus y1. Be careful those double negatives. So that'd be negative 9 and 7. So that means it starts here. In other words, that moves here, and then negative 9, 7, 3, 4, 5, 6, 7, 8, 9. And then I'll put 7, 1, 2, 3, 4, 5, 6, 1 up from there, right about there. Perfect? No. But that got moved to here. What's the magnitude? Well, this is negative 9, this is 7. We just need to find the length of the spinner. So a squared plus b squared equals c squared. Take the square root. So that'd be 140. Now that could be broken down perhaps. Wait, 130. 130. Now, what about the direction? Well, I'm going to use some trig here. I'm going to stick with tangent. So I'm going to go tangent of theta, because I didn't want to deal with the square root, equals 7 over negative 9. So I get my handy dandy calculator out. So second tangent, negative 7 divided by 9, enter. I get negative 37.87. Negative 37.87. Let's call it negative 37.9. Now, it's like, whoa, wait a minute. That's not down here. See, your calculator doesn't know what quadrant you're in. So I just told you that this is 37.9. But that's not the direction angle. The direction angle is how far you had to spin your spinner to get there. So that'd be 180 minus 37.9, which is 142.1 degrees. This is your reference angle. Your direction angle is how far you spin your spinner to get to that story. And here this last question is, find a vector with same magnitude, different direction. Well, I would just go down here and say, okay, there's the square root of 130, and steal this. So that would be 9, negative 7, and there it is. Done. Good luck on your homework.